Good morning, everyone. Thank you so much for joining the Redington virtual sessions. Today's topic, we have Micro Focus Fortify, Securing Application Source Code, and the topic will be delivered by our lead consultant, Mohammad Sirajuddin. In case you have any questions during the session, I would request you to please put it in the Q&A box, and Siraj will answer all of your questions at the end of the session. Siraj, over to you.
Hey, Bindia, thank you. Thank you very much. Hi, everyone. Good afternoon. This is Mohammad Sirajuddin. I'm the lead consultant from Redington, working on the Micro Focus portfolio, the security portfolio. And in our today's session, we are going to talk about security application testing. Static application security testing, which is to ensure how are we going to secure our source code. In today's discussion, we'll discuss on a brief overview on the development lifecycle, what the development lifecycle should look like, what it is actually going, and how exactly it should look like to ensure that we have a secure development. We'll look into Fortify SCA, which is a static application security testing, and we'll have a demo on this. So let's begin to understand what the software development lifecycle is going through and what it can happen, what it can be. We have some statistics. If we look into some reports, be it report from OWASP, be it report from Mandiant, be it report from Gartner, be it report from Homeland Security, multiple sources, everyone hint that the major area of attack is the applications, because they are freely available, easily accessible by the hackers. That becomes the de facto attack vector for a hacker. So it is very important that we have proper applications developed with full security imbibed in it. If we look into today's scenario in our organizations, we have some of our organizations are still using legacy softwares. Some of them are using in-house developed software. Some of our softwares are outsourced. Some of the softwares we procure directly from the third parties, and some of them we use open source. So we do have a mix and match of various components comprising our application environment. What is most important in this aspect is to ensure that we are meeting the security. We are ensuring that the security is met. We are ensuring that the compliance is achieved. How do we achieve this? We need to ensure that we are having a securely developed source code, and we are protecting the applications which are in production. So if we talk about software security assurance, meaning that a software which is developed or which is utilized in our organization is providing a security assurance for us. Like, we are assured that there are no security breaches or vulnerabilities within the piece of code that we have developed. How do we do that? How do we ensure that our applications are running with proper security imbibed in it? The very first thing is ensuring that the developers in our organization are developing secure source code. The source code that is developed is secure. Once the source code is developed, and when it is passing through the business logic, or it need not at the second level, it not be only the developed source code. It can be our commercial applications which we are purchasing, even those when they are installed and deployed in our environment. When the business team goes through this application and confirms that yes, it is meeting the business logic, then we have to go perform a security testing and ensure that the kind of deployment that has been done, the kind of security it is expected to meet, it is expected to have, is in a perfect condition. So we need to do a second layer of security testing. And once the second layer of security testing is done, we proceed with the production. Once the solution is and once the application is in production, it is very imperative to have its monitoring done. So these are the three modes where we are, if we have developers, or we are developing an application from scratch where we have the developers existing, we need to ensure that the source code developed by them is neat and clean. Once it is developed and once we are into the deployment stage, probably we call that as the staging area or the pre-prod area. So it varies, whatever we call the terminology, whatever the environment we are referring to. Ideally, I'm referring on the stage 2, I'm referring to the pre-prod area or the staging area. So once we get a go-ahead security testing is done at pre-prod and staging area, when it moves into the production area, we need to have a third module installed, which is continuously monitoring the applications. This, if we have in place, then we can be assured that yes, we have followed the best practice, we have followed security assurance, we have a security assurance model. If you look at some of the numbers, some of the statistics from past 10 years statistics, if we look into it, we see that 10 years ago, when the application was released, there were very few updates released to it. As and when the time has been passing, we see now that for an application that is released, there are very frequent updates released to keep it healthy, to keep it protected. This indicates that the number of the frequency of updates released has increased only because the sophistication of attacks, because the increased number of attacks on the applications. If we look at some of the big say, like the Gartner, they say that their biggest suggestion comes at a place where they say that the DevOps team have to collaborate with the information security team to ensure that the development is actually in a secure way. Fixing the vulnerabilities at the source code level is of extreme importance. It gives a very good return on investment for us because we are fixing it at the development layer. If we talk about DevOps, the methodology, this is today is being adopted by extremely almost all organizations because the DevOps methodology is going to rapidly help us in developing applications. The developers think that the DevOps is helping us in creating the application. The DevOps thinks that the developers thinks that the DevOps process imbibes security in that by default. At least 99% of the developers think the same. But when how many of them are actually going with the security testing? It is less than 20%. Less than 20% of the team members get into security. So in today's DevOps, which is being the DevOps operations that is happening, where is security imbibed in it? Security is missing. This is a very fragile component that needs to be a part of the development. Today we are growing at a rate of 80:1. 80 developers is to one security team member, where security has to be a part of our development process. How is Fortify helping us in achieving this mechanism? How is Fortify helping us? When we are at the code level, when our team is developing the source code, we have Fortify SCA, source code analyzer. Today's topic is all about static analysis, but I'm just giving you the brief overview of what Fortify does. Then we'll have a discussion on SAST, static application security testing. So once the developers, the very first stage, the second stage where we are into the development stage and the developers are developing the source code, we have SAST in place. We need to utilize SAST to review and ensure that the source code is neat and clean. Once we get a neat and clean source code, we get into the testing phase or the integration or the staging area. That point of time, we need to utilize and we need to perform a dynamic application security testing. We have a product called Web Inspect. We have already delivered a webinar on that. Probably on our YouTube channel, you'll be able to find the video for DAST as well. So DAST is extremely important because this takes 360-degree view of an application. This level takes only the source code application, source code into picture. Here, we do not take the source code in picture exactly, but we test the source code that has been developed. The testing of the source code with a rigorous attack happen at this level. Once we have gone through the DAST process and ensured that the application vulnerabilities are fixed, we move on to the production environment. The production environment, we all know very well, like an application that is developed by us, an internally developed application, will not have an extremely well developed logging. Logging is more important because logging is a component, and because logs are the most important component which gives us visibility, which gives the security team visibility into what is happening with the application. So if the development team has developed an application which is not comprehensive in writing logs, or which is not generating enough amount of informative log or security based logs, it cut off the visibility to the security team. Security team will not be in a position to monitor it. So we have a runtime application protection module whose main functionality is to monitor the application. It's an agent-based solution which is installed into the application server. This agent is continuously monitoring the calls, like what is the call coming to the application, how is it responding, and on each of the call, the runtime application protection agent sends logs to the SIM solution in a syslog mechanism, or it can be in a CSV format. It's up to you how you want to utilize the information. How does the security team want to utilize the information? It is up to them how they want to utilize it. But the RASP product is monitoring the application. It also has a protection module. If enabled, it can protect you against attacks like the SQL injection, cross-site scripting, multiple attacks. It can protect you. There is a big difference between the RASP production as well as the WAF. We might think that it's the same job as WAF. No, it's different. It's different. WAF never provides you an application logging, but runtime application protection is majorly for your application monitoring and logging as well. So let's proceed further to understand further components. Each of the level, we have a different Fortify product. For source code level, we have source code analyzer. For the testing level, we have Fortify Web Inspect. For the production, to monitor the applications in production, we have the third module called Fortify App Defender. These are the three major products that we have. Software Security Center is the management console, which is like the single glass of pane, which provides visibility to what applications are there, what vulnerabilities are there. So this gets integrated with each of these applications. You can integrate Web Inspect with SSC. You can integrate SCA with SSC. So SSC becomes the central module which gives us the visibility of visibility of the security posture of our applications. We also have a Fortify On-Demand module. So the above module that we discussed is an on-premise based module. It is existing on-premise. The module that you see at the bottom is Fortify On-Demand. Is a SaaS based service. You do not need to deploy anything. You can buy credits, the subscription credits. Once you buy the subscription credits, you get a tenant allocated, and you can utilize that tenant to scan the applications. It can be a source code scanning, it can be a web application scanning, or it can also be an app defender. Well, a few points on the Gartner Magic Quadrant, probably around 8 to 9 years that I would say we are into the leaders quadrant. And we have probably we would say Fortune 500 companies, or I would say the Fortune 100 companies are actually working with us. We have big names like SAP, Microsoft being customers with us. We banking customers are one of the major customers who, in this particular region, we do have the major customer base from the banking segment, banking and finance segment, the government segment. It's very well recognized application. So what does the Fortify customers experience? Fortify customers experience an extremely higher, faster rate of fixing vulnerabilities. At the development level, we fix the vulnerabilities. We identify the vulnerabilities very early. We help the development team to develop the source code in a better way. We ensure that the applications developed or deployed are as per the best practice. Let's focus on today's major agenda, which is static application security testing, SAST. This is also referred as a white box testing. The dynamic application security testing is also referred as a black box testing. This is the generic typical names from a QA point of view. So as a QA, if I'm a QA, I would refer this as a white box testing. So, but the Gartner and rest of the world recognizes this as security application, software application security testing. So SAST is a process, is a methodology that helps the developers develop source code in a secure way. The Fortify SCA has IDE plugins which the developers can use for their environment, like their development environment. It can be a .NET framework like Visual Studio or a Java framework like an Eclipse. We have an IDE plugin available for these frameworks. The developers can utilize these IDE plugins and ensure that they develop whatever the code they are developing is actually secure. There are no vulnerabilities in the piece of code that they have developed. As a result, the quality of the source code that the developer commits to the repository becomes extremely better without the IDE plugins. Let's go through a process to understand how the SAST team, how the development team will work once we have Fortify SCA in place. We are describing the workflow, not necessary that it has to be it has to exactly be the same workflow. The workflow can be customized based on your organizational requirement and priorities. Okay, let's start. The step one starts with the developer. We have the developers with us, and the developers are using the IDE plugins, meaning that each of the developer in his development environment has the Fortify IDE plugin added. So as a result, whenever he is developing the source code, before he commits the source code, he is reviewing it using the Fortify plugin and ensuring that whatever he has written is clean. So now the developers commit the source code to the repository, the source code repository. The source code repository we can now directly move on to the step 3, or in some scenarios, the development team has a component called continuous integration server. So so the source code repository is integrated with the source code with the continuous development or the continuous integration. So now the QA or the developer commits or instructs the continuous integration server or the SCA server to go ahead with the static scanning. So for example, example of continuous integration server or the development servers can be Jenkins, TFS, Visual Studio. Jenkins majorly I have seen integration. We do have integration with TFS as well. So whatever the CI/CD environment you have, you can utilize that, and you can instruct the CI/CD environment to first go ahead with the source code analysis. The CI/CD environment comes to the server where we have the SAST tool installed, Fortify solution, Fortify SCA installed. So Fortify SCA, based on the inputs from CI/CD or uh, based on the information shared by the source code, it performs the scanning of the source code. It does the analysis and it uploads the results to the Fortify SSC. Remember Fortify SSC, which is the management console? It uploads the results to the Fortify SSC. And now the step 4 is the auditors. The auditors, they can be the QA, the quality analysis team, QA team. So the QA team logs into the Fortify SSC and checks what vulnerabilities are there in the application that has been developed by the development team. So he reviews the QA. There are chances of whitelisting to be done. False positives can get into picture. The vulnerabilities will definitely be there. So the QA team reviews the source code that has been identified. If there are any false positives, they will whitelist. They will give a reason saying that, yeah, this is not a vulnerability. This can be omitted. So Fortify SCA and SSC both gives you a framework where you can whitelist the vulnerabilities and by giving a proper reason to it. So if the auditor finds, yes, this is the vulnerability identified by Fortify SCA is actually a real-time vulnerability, then the QA team, the auditor, files a bug into the bug management tool, bug tracker like Bugzilla, Jira. We have direct integration with bug tracking tools as well. So it integrates with the bug tracking tool, and from here, the bug tracking tool, it goes back to the developers. The developers gets notified from the bug tracking tool saying that there is a bug in the software that you have developed. Work and fix it up. So this is the entire life cycle. So now once the developers work on the bug, they will repeat the cycle again. So the quality, the auditors will review again, and if there are any bugs, they will follow the same cycle. So this cycle will be repeated until we do not get the neat and clean source code. Regarding the open source component as well, the format is same. The source code, whatever you have open source, you will be scanned against the SCA, Fortify SCA tool. Any vulnerabilities on that will be filed as a bug, which will again then be followed by the development process. So what does Fortify SCA or the SAS technology helps us do? It helps us in identifying vulnerabilities at the very early stage. It helps us fix them at an easy way, thereby helping us in reducing the time and the cost involved, thereby providing us a better return on investment. In a nutshell, the source code analyzer is supporting a huge number of programming languages. We will look into the kind of languages that it supports. And the vulnerabilities found are up to 95% reduced false positives. We have a different mechanism. We'll discuss that as well. We have IDE plugins for the developers where the development team can utilize the IDE plugins, which helps them extremely to a bigger level to develop the source code neat and clean. We have integrations with the CI/CD environment for a continuous build process, and we can scale to a bigger number of applications using cloud scan technology. This is a small screenshot of the kind of integrations that we support. People from the development and the application security team will clearly understand the kind of environment that has been represented. This is a small snippet about the programming languages that we support. Probably you can say 95%, more than 95% of the organizations, whatever they use, the programming language is supported. Honestly, I haven't come across a customer who said like they use a programming language which is not supported by Fortify. We support almost everything that an organization uses on a day-to-day basis. This is a screenshot of the Fortify SCA, how it looks like. I'll not talk in detail about this. We'll look into we'll look into the demo directly in this. Just to give you a nutshell, here we have the exact line of code that describes what vulnerability is this. We have the proper explanation given of why is this being considered a vulnerability, and we also have we also have issues detected. This is not exactly the of a Fortify Audit Workbench. This is Security Assistant. Security Assistant is the real-time source code analysis mechanism. So basically, what is happening for a solution like Eclipse, you see HP Fortify added here as a code, as a IDE. So as and when the developer is writing the source code, as and when he is writing the source code, vulnerabilities are identified. And you click on this, you get to see more vulnerabilities. You get to see the details of them. So this is not on a Fortify tool. This is within the developer's tool. We have a plugin, and as and when the developer is developing and writing, we are identifying the vulnerabilities and helping the developer fix the vulnerabilities immediately as and when he is writing. So apart from that, we discussed on the Fortify Software Security Center. Fortify Software Security Center, we call this as SSC, which is the management console. As I said, it helps us in vulnerability management and application lifecycle. So it helps us identify what vulnerabilities are existing in our applications, how many of them are fixed, how many of them are not fixed, which developer. It allows us a framework to log in, a framework where we can assign specific vulnerabilities to specific developers, so that the developers can in turn log into SSC, fix the vulnerabilities, and update the case management. So as a result, we get to see we get to see that the SSC is the main console which helps us manage the vulnerability status of our applications. So a snippet would look like this: Fortify Software Security Center. As I said, SCA can be integrated with SSC. So it is not necessary that you need to log into SCA tool to understand the vulnerabilities. You can directly log into the Fortify SSC and you can understand the results directly. You see the line of code mentioned here. You see the remediation mechanism, how to fix the vulnerabilities is mentioned. You see the exact details of the vulnerabilities that have been identified. It gives you a proper dashboard. The dashboard highlights, it tells you each of this is an application, and each of the application is telling like how many vulnerabilities exist within them. You have a reviewed column, you have pending review column, which tells like what has pending review is nothing but vulnerabilities which people have not even looked into, the team has not even looked into. Reviewed column, where the team has looked into it and have commented on the vulnerabilities. So it gives us different kind of dashboards on the basis of categorization, different way of representation. Probably the moment I look at this dashboard in SSC, I can say that three major vulnerabilities exist, which when fixed, I would say 70% of the vulnerabilities will be fixed. Looking at this diagram, privacy violation, like examples would be like password included, password hard coded into the source code. Cross-site scripting reflected, cross-site scripting persistent, both similar category but at a different places. So if I fix these three vulnerabilities, probably I'm fixing 70% of my vulnerabilities. So I allocate accordingly, my vulnerabilities posture gets better. So as we discussed on false positives as well, there are chances based on the application logic, application framework. There are chances that there might be some false positives as well. There might be majorly there will be true positives, but there can be false positives as well, and there can be something which can be highlighted as not vulnerable. Some of them are not exploitable. So how are we? This is the way how the result will be classified. It is classified on the basis of critical, high, medium, low, not an issue. So we get a framework to whitelist. We also get an automated framework called Audit Assistant, Fortify Audit Assistant, which is a machine learning based technology, artificial intelligence based technology. What does it do is, this is existing on the cloud platform, where the vulnerabilities are reviewed using artificial intelligence to identify what is a false positive in that and what exactly is not a false positive. So the result shared by Fortify Audit Assistant can be considered that 95% of the vulnerabilities which are identified, which as termed as exploitable by Fortify Audit Assistant, is actual vulnerabilities. So you can heavily rely on Fortify Audit Assistant's report. So whatever it identifies and says this is a vulnerability, definitely there is 95% of the chance that it is a vulnerability. Fortify Ondemand. Fortify Ondemand, as I mentioned, is a cloud-based service. There is no challenge for you to. There is no issues. Headache for you to deploy and provide the infrastructure. All you need to do is log into the portal, into the tenant that has been provided, using the credentials that has been shared. Log in, select the type of scanning. If you want the web application scanning, web inspect scanning, select the web inspect scanning. Or if you want source code analysis to be done, select the source code analysis scanning, and you are good to upload the source code, and the scanning starts. So based on the kind of scanning that you have selected, you also get a technical account manager allocated who helps you in understanding the results and explaining what the results actually mean. So at the moment we have 4 data centers where the scanning happens. Since Fortify Ondemand is a on cloud based solution, we have cloud in 4 different regions, which are listed here, and 24/7 customer support. So, well, now with this, probably we have come to a conclusion. We have concluded. We have seen what Fortify has to offer for application security testing, and what we have seen in detail of Fortify static application security testing, Fortify SCA. Now, let's have a look into the demo. Let's see how Fortify SCA looks like. I'll open the Fortify Audit Workbench. It's a very straightforward, simple to install tool. Next, show the license, and it is done. Nothing much. Now, as part of my configuration, Fortify Audit Assistant, probably the Fortify tool needs to have a set of rules to validate the vulnerabilities against. Now I have multiple configuration. What is the frequency of the rules which I'm talking is about the updated rules? What is the frequency of this? It can be, I think, to my best of my understanding, it is released every 3 months, once in every 3 months. There are 2 mechanisms. One, you have direct connection to the internet using proxy. We have a specific URL, port number 443 HTTPS. You can allocate port 443 HTTPS access so that the Fortify Web Inspector, so Fortify SCA tool can connect to the internet before initiating the scanning, and ensure that the rule pack that it has is latest version. Or if I have a air gap network where there is no possibility of internet, you can open a support ticket. Support team will give you the rule base. You can bring the rule base, come to your air gap network, run a single command, upload the rule base into the Fortify Fortify SCA, and you are done. You don't even need a direct internet connection. Manually, the Fortify SCA or Fortify Web Inspect, in that case, both works in an area or in an environment where there is no internet availability as well. So as of now, I'll click yes, so that it goes reviews. Fine, it has done, it has reviewed. no updates required, no updates were there because recently I installed this. Now, let me show you how do we initiate a scanning. So if I have to scan a source code, I click on advanced option and I showcase where exactly is my source code. So right now I had a source code available, which is within the samples. I had selected WebGoat as an application. People know people from the application security background might be aware of WebGoat. WebGoat is a purposeful built vulnerable application just for the application security testing purpose. So this WebGoat, we select WebGoat, okay, and I say yes. Don't ask me again. So auto updating rule pack. So finish operation. Yani it updated the rule packs. Now I selected the WebGoat. A WebGoat application. Look at the flexibility here. I have the option of specifically removing specific files. So some of the developers might say, don't consider these specific files. So I can exclude them. So as of now, in my scenario, I'm going to use the same thing. JDK is 1.8. You can select based on your availability output file. You click on next. Here you get configure the rule packs probably. This is the list of default packs. The moment you saw update security content, these are the list of rule packs that was downloaded. Fortify also provides you a framework to create your own rules. So if you have created some specific rules as per your requirement, you can click on custom security rules and then select them. So as of now, I do not have any custom security tools rules, so I'm just going with the default one. I'm running this on a laptop, so on my office laptop, which is just having a 8 MB RAM. But here, when you want to work in production, you need to have a bigger RAM based on your application size. So you can modify it. You can modify, reduce whatever you want. You can assign that. So I'll go with the default. I click on next. This is something that talks about how do you want to display the results. Show me all issues or show me likely problems. Show me only the remote exploitable issues. I've selected show me all issues. Show me all code quality. Is this a Java? Yes. Does the program runs with escalated privilege? I've selected yes. So now I click on scan, but I'll not click on the moment I click on scan, it will do the scanning and we will see the results. So I have already initiated the scanning. I've already done the scanning. You see the result here, WebGoat 5.0 and April 28, which is today's date. I had already done the scanning. So I will not click on scan. I'll cancel it. So I did this just to demonstrate to you how the process looks like, of scanning the source code. So the moment you click on scan done, nothing to be done. Fortify tool or Fortify SCA will automatically scan the source code, will show you the percentage, and once it is completed, it will open the result. So I'll cancel it. Now, when I said it will open the result, how does it look like? It will look like the same way. I just click on this. It is opening the result. It is loading the audit project. Yes. Now, this is what, if you had clicked scan and waited for a couple of minutes, it would have given you the next page was the same page that you see here. So now it is the GUI of Audit Workbench is divided into multiple phases. This part is where we get to see the vulnerabilities vulnerability information, what vulnerabilities are there. On this path, this side, we see the functions, what functions is being called. This is the main area, which you call it as the central area, which displays the actual source code. At the bottom is where I identify what details about the vulnerabilities that is listed here, and recommendation mechanism, history, diagram. And here is the analysis trace. So let's do a small review of web inspect vulnerabilities that we discovered. So the project summary, if I look into the project summary, it gives the build ID. It tells me that it has 190 files, 8,905 line of code. Remember one thing, I have selected the quick view. There are two views here. You can modify and select whichever the view you want. By default, we go with security auditor view because that gives more information, in-depth information. So I select on security auditor view. So the moment I select security auditor view, the total number of issues now has increased to 1,279 because it considers many aspects as part of this view. Now, each of this view is classified into different criticalities. You see here, I have 265 critical. This is my high, 99 high vulnerabilities, medium 11, 904 is low, and all I have this other, the remaining is all. So I'm going to close this. Let's go on to the critical ones. This next layer of filtering is categories. So category here, the one that is, this is the default one. The default one is basically on the type of injection, on the type of vulnerability, it is classifying the results. Now 265 vulnerabilities are classified into 1, 2, 3, 4, 5, 6, 12, 12, 13. So 265 vulnerabilities are classified into 13 different categories. So now, for example, how do I understand this? SQL injection. Okay, example. So there are, out of 265, there are 43 instances where there is a possibility of SQL injection. And what is the zero indicate here? Zero indicate that of the 43 vulnerabilities of SQL injection, zero is fixed. Now, you remember there are 8,000 lines of code. So now somewhere there is SQL injection. I have no idea where exactly is that. I click to see more. So I get to see the list of 43 vulnerabilities which are related to SQL injection. Now, I click on any one of the SQL vulnerability here. So what happens the moment I click on this? How do you read this? The very first line until this colon represents the file name. After the colon, it represents the line number, which means the vulnerability, this vulnerability is in blind SQL injection.java file. And within this file, line number 122 is the actual place where exactly the vulnerability exists. So since I have highlighted this, automatically it shows line number 122 highlighted. And this is the reason. This is the actual place where we have a vulnerability executing. You can see here, it's a statement.execute query. Yani, there is a query which is getting executed at this level. So what is this? A person like me who have absolutely no application security, application development background, look how beautifully it helps people like us. I'm from security, pure security background. I have never done a application development, a program development environment. But still it gives us very decent information to understand this. What exactly is this? This is an abstract which gives us on the line number 2, the methodology. It gives you detail like an SQL built with input that comes from an untrusted source. It is saying that the source from where the input is coming, it is not trusted. If I want to understand more on this, I can click on details. So when I click on details, it gives me further more explanation what exactly is the meaning of this, and it gives me different examples. How do I different examples helping me to understand this vulnerability in a better way. So here it gives you the example, and here it explains the query intends to execute the following code. This is a vulnerability example. So it is trying, it gives its best to explain to you on how exactly this vulnerability, this is a vulnerability. It gives you full information on that. Recommendations are a part of this. The moment you click on recommendation, they are the ones which tells you how to write the code. How can you fix this vulnerability? And it will give you some examples. Not every time, but majority of the time it gives you vulnerable examples on how exactly are you going to fix this vulnerability. So where are you going to authenticate? Where are you going to validate the user input? And then you have further more information based on the components. The important thing to focus here is we are talking about SQL injection. All I see is a statement which is getting executed. But where is it coming from? What is it executing? How is it happening? I have no idea on this. So the analysis trace is going to give me this. The analysis trace is, right now we are at line 122 is where our vulnerability is. So line 122 is highlighted here, but it shows us, line 122 about the trace from where the information is coming in, from which page, from which line number the information is coming in. It's coming from 629, 630, from where the assignment of values, sorry, it has to go up. Get parameter, yani this is the place where input is being taken from the user. We are collecting an input from the user, and then at the last phase we are executing that, collecting from getting the input till executing the query. So it is considering the entire phase where exactly the vulnerability is happening. Based on that, it is giving you an analysis trace saying that yes, this is a vulnerability. This is what I consider as a vulnerability. But looking at this trace, if the auditor says, yeah, no, it's not a vulnerability, we can suppress this vulnerability. So based on the user, right now I have not created users, else you will have to log in with a specific username, and you have to enter. You have to enter the details here, saying this is not a vulnerability. Why is this not a vulnerability and not an issue? Or you have to mention it as suspicious, or you can say this is exploitable. You can say it is, for example, right now this is exploitable. So you can write down your details, or you can information on this, that this, whatever the values you have, you can select and you can commit. The moment you commit, the value is added there. So the auditor, so it will not do it because I don't have the source code, I don't have the username created. I'll not do that. So it ensures that whoever is suppressing an issue, there is an audit trail for it. So tomorrow, if the same vulnerability on this particular line, on this particular page, the page responsible for executing this line is identified in WebInspect in the DAST scanning identifies, yes, there is a SQL injection, and it highlights something which is coming to the same page or same query, then we will have an audit trail to tell us why did the developer suppress this issue. So you have a proper audit trace available with you. So apart from that, you also have proper reporting available. You can so you can upload the audit project. You click on upload audit project, you can do that. And apart from that, you have reporting. You can go generate the BERT reporting on this. Say for example, I want a OWASP top 10 report. I click on OWASP. There are multiple categories of reports that we have. Developer workbook is going to give me in detailed information about each vulnerability. We have GDPR, you have OWASP, you have FISMA, you have PCI. I'm selecting OWASP top 10. The latest is 2017 OWASP top 10, and after 27 it is not yet released. I click on detailed report or whatever you want, you can click on this. There are different formats that you want, you can select it. I'm selecting the PDF format, and I click on, here is the location where it is saving. Let me just pick up this location, generate. So it is generating the vulnerability. So let me copy the location. So report was generated successfully. So now I need to open the report. You can have the reporting mechanism configured properly, where it can where you have a specific location, your defined location. Those are the minor Fortify changes that you can do. I have got my report generated here. I click on this. OWASP top 10. All A1 to A10, all vulnerabilities are defined here. So this is the summary page which talks about what is the vulnerability status. As per OWASP top 10, I have vulnerabilities at each of the level except A8 and A10. At each level, I have vulnerabilities. I go further details. It tells me which amongst the rule pack that we had selected, which are the rule packs that are triggered. Now it gives me more detail. For example, as per OWASP top 10, A1 category of OWASP is talking about injections. So now in the injection category defined by OWASP, my application has 81 issues. So of these 81 issues, 48 are critical, 11 are high, and 19 are low. Similarly, you have classification for all A10, what vulnerabilities exist. So starting A10, then we have A1 injection again, giving information in detail. What vulnerability is this? Out of A10, what are the different command injection? How many you have? You have 3. You have dynamic code evaluation. How many? 1. So it's going to give you further classification. I did not click on detailed report. If I click on detailed report within top 10, then I would have got every single detail of this vulnerability. One injection, I have one dynamic code injection. It will put a screenshot of the dynamic injection source code and gives explanation and remediation how to fix it. So this is how the reporting as well works. Probably we have covered almost everything within the source code analysis. You have seen how Fortify, as a summary wrap up, we have seen how Fortify helps us in achieving the software security assurance. We did a deep dive to understand source code analysis. We saw what source code analysis is, how does it help us, what are the different mechanisms. We also did a demo. We understood how the look and feel, how easy is it to install, how easy is it to scan a source code, how easy is it to navigate the source code and understand the results. We did a small demo on this. I believe this has been informative to you. I conclude my session with this. Let me just go ahead. Bindya, over to you. I have finished the session. Okay, I believe there are no questions coming in. Thank you very much for your time. In case if you have any questions, you have my email address mentioned. This is my email address. You can reach out to me any point of time. Will definitely be more than happy to support you in addressing your concerns or helping ensure that you work with the properly secured applications. Thank you very much for joining. Bindya, you there? Okay. Thank you guys. Thank you very much for joining this session. I'll conclude this session here. Thank you very much.